Hi folks, Mr. Long here. I'm going to do a screencast for how you solve for an exponent in an exponential equation using tables and graphs. Okay, so in the course that we're currently in, we don't have to do this with algebra. That comes in a later course. What we do have to do, though, is use guess and check, which is basically with a table of values, and we also need to be able to do it graphically with something like Desmos. Here's an instructional problem that we're going to look at. It's about a car. A used car gets bought and its value decreases exponentially after it's purchased, right? Which makes sense. Cars decrease in value. It's called depreciation. They go down in value every year. So this car was $20,000 when it's purchased, and it keeps 84% of its value every year. So that means it's losing 16%. Every year. Okay, so the value V at time t in years. So part A says create an exponential equation that can be used to determine when the value of the car is equal to the noted values. I should say values right there, not just value. Okay, so half its current value. So what we want to do is, how long does it take until the car is going to be worth half of this 20,000? So I think we're pretty confident in that we can write this equation and say that 20,000 multiplied by 0.84 to the t will equal 10,000. Okay, that's to get it halfway. That's what we're going to get. So we start at 20,000 and we end up at 10,000. Well, there's one bit of simplification that we can do, even if we're going to do guess and check, and that's to divide by that $20,000. Okay, divide both sides by 20,000. And then we're going to end up with 0.84 to the t will equal 1/2, right? 10,000 divided by 20,000. So that's what our equation will be. We need to solve that equation by guessing and checking and using graphs, okay? Or I can also solve this equation if I want. It's a much simpler equation to solve. 0.84 to the t equals 1/2. Okay, and that came from dividing both sides by 20,000. Taking 10,000 and dividing by 20,000, which is 1/2 or 0.5. Okay. So let's look at this graphically. So I've got the graph here. You can see, and I cut and pasted this out of Desmos. You can see that I entered in the original equation, 20,000 times 0.84 to the x, and then I set a y value equal to 10,000. So y equals 10,000 is a horizontal line. Here is the exponential curve with a y-intercept of 20,000. You can see it's decaying exponentially. It's asymptotic at 0. There's an asymptote at y equals 0. And all I have to do is find the point of intersection. So it looks to me like at 3.976 years, it's 10,000. Now, by the way, you're going to have to do some fooling around with the graph in terms of the scale, right? You can squeeze and pinch, or pinch and zoom, I guess you call that. But you know the y value is going to have to be at least 20,000, right, to see the whole graph. And really, I didn't need to show this part of the graph down here because I know that I'm trying to figure out when it's worth 10,000. Okay, I want to figure out when it's worth 10,000. So again, that's just a Desmos graph, and I can simply say that x equals 3.98 if I round it years, so that's really 4 years. So with 4 years of depreciation, that new vehicle, not a new vehicle, it's a new to the person, but a used vehicle, goes from the purchase price of 20,000 down to a value of 10,000. Okay, that's how you do it with Desmos, and that's how you do it like on something like an assignment. But what about, oh, remember, pause it at any time, rewind, go back over things. But guess and check, which is how you're going to have to do it on a test. Well, if you remember what we did, and I'm just going to scratch that out right there. The equation that we wanted to solve was 0.84 to the x is 1/2 or 0.5. Okay, so that's what we're solving. So what I'm going to do here is I'm going to guess different values for that x until I get an answer of 1/2, right? So I know an exponent of 0, that's obvious, it's 1. I'm going to do an exponent of 2. I know exponent of 1 is going to take me to 0.84. So what I'm going to do is substitute that in. So I'm going to sub in 0.84 to the 2. And 0.84 to the 2 will give me 0.71. Then I'm going to sub in 0.84 cubed. And the question is, do I have to go higher? Do I have to go more years in the future? Yes, because I'm only at 0.71. I've got to bring it all the way down to a half. Okay, I'm bringing it all the way down to a half because I want to have half of my original, half the original value. So I do 0.84 cubed. 0.84 cubed takes me down to 0.59, not far enough. So then I go 0.84 to the 4th, and that takes me to 0.5. Oh, look, that's where I wanted to get. So before, when we did it in the graph, we did guess and check, and we got, sorry, on the graph we didn't have to do guess and check, we just found the intersection point, and we got x equals 3.98, which is basically 4, right? So our answer is x equals 4, which is just fine. Now sometimes you're not going to find it as easy to guess 2, 3, 4. You might have to skip more forward into the future, like into 8, 9, but all you do is you again, it's guessing and testing, right? All the time, guessing and testing. Okay, so let's see here. We need one more question I'd like to look at. And one of the questions was, well, when the car was new, it was $26,000. How long ago was that purchased? The brand new car. So you can see right here, if you look at the curve, when it was purchased used, which is, so it was purchased used, say today, it was $20,000, and then it decays in value over time, right? But what this question asks is, well, how many years ago was the car purchased? Because it was purchased for $26,000. So I've got to go into the past. So how far into the past do I have to go? Right, that's what I'm trying to figure out. So I look down right there. So how many years ago was it in the past? So what I can do here again is divide both sides by 20,000. And if I divide both sides by 20,000, 20 divided by 26 is 20 over 26, which is 10 over 13. And so, or rather 13 over 10, my apologies. So I end up with 1.3 equals 0.84 to the x. So again, I make a table of values. And then 0.84 to the x equals 1.3. Right, so that's my goal. I want to get a y value of 1.3. So the first one, does it make any sense to try 0? Well, no, that's going to give me 0.84. And remember that I've got to go to the past, right? Because I'm trying to get the value or the amount of time it took in the past when it was worth 26,000. So I might try -1. If I sub in -1, I'm going to have 0.84 to the -1, and that will equal 1.19. Okay, that's not far enough. I need a bigger value. Okay, I'm getting 1.19, but I want my equation to be worth 1.3. So I have to go back further. So let's go back 2 years in time. Then it's 0.84 to the -2. And that's going to be, how much is that? Well, that is 1.42. My target value is 1.3. Well, 1.3 is in between 1.19 and 1.42. So I'm going to have to try something in the middle. And here's where you might have to do this a bunch of times, right? You're just going to have to be fast with your calculator. It works out that -1.5 gives us, the answer is that 1.3, okay, which is the right answer. So that means x equals -1.5, or the car was purchased 1.5 years ago. Okay, 1.5 years ago. it was worth $26,000. Okay, so this is really, the idea with this is you simplify the equation, right? You simplify the equation, and then what you have to do is guess and check, guess and check, guess and check. Okay, you get it into this form right here, and you try and get it as close as you can. And you know what, if you only got this one to 1.31 or something, it's fine. You're just trying to get it as close as you possibly can. Alright folks, so that's how you go about getting guessing and checking. Now I will say if you have a half-life equation, so supposing you want to solve this equation, 10 equals 3 times by 2 to the x over 4, it's exactly the same thing. You would divide both sides by 3 and you'd get 10 over 3, which is 3.333, etc., repeating, and you would end up 3.333 would equal 2 to the x over 4. And so what you're going to do in your table when you guess and check this one is you're going to have x, and then you're going to want to have 2 to the x over 4 equals 3.33. And again, you're going to do guess and test. So you know it's in the future at some point, so you might try 1, try 2, try 3, and keep going until you can get it close to 3.33. Okay folks, so it's no different if you have a doubling time or a half-life type formula. Okay, so go ahead and make sure you work through all the questions. This is on, oh gosh, I didn't even check what tile it was. You know what, it's I'll send out a remind to tell you what tile it is. Okay folks, good luck with your work.